In this video, I'd like to show you how to calculate the area under a curve such as fx, which is bounded by the x-axis as well as intervals a and b. What's important about this is that we're not doing the area under a straight line, but it is a curve. And this is done by integration. If it was a straight line, when we could use the geometric arguments by using areas of triangles or squares, but in this case it's a little bit more difficult. To find this area, we're going to use integration method, which means that we'll use that sum sign here from area from a to b of that function fx, and we're going to integrate it with respect to x. For example, let's have a look at this function over here, which is 2x squared, and it's bounded by 0 to 2, the blue area. Let's consider the blue area first, from 0 to 2. So we'll look at the blue area, which is bounded by the function, the x-axis, and intervals 0 to 2. And this will be written by the area is the sum of, or the integral from 0 to 2 of our function 2x squared with respect to x. And integrating this using the rules of integration will just gives us 2 to the power of x to the 3 over 3. Since this is a definite integral and it has lower and upper boundaries, we'll need to put these square brackets on it, 0 to 2. And substituting first of all for 2, we'll have 2 to the power of 3 and minus the substitution with 0, which is just going to gives us a 0 anyway. We are left with 16 on 3, which is 5 1/3 square units, because this is area. If we're to do the green area, it's bounded by 2 and 3, so we could work this out by saying that area is equal to, from 2 to 3, the integral 2x squared with respect to x. And that is going to be, as before, we'll just write them in square brackets, x cubed on 3, and we are now bound by 2 to 3. So we will need to substitute first of all 3 into here and take away with the 2 substituted. That becomes 2, 3 to the 3 over 3, and on this side we'll have 2 times 2 to the power of 3 over 3. Just working that through, I think that's 50, 27 times 2 is 54 over 3. Take away 16 on 3, which will leave us 2. 38 over 3, which gives us 12 and 2/3. Once again, this is area, so we'll call it square units. So this is the way we calculate the areas of regions which are bounded by the x-axis, and these functions or curves need to be above the x-axis. If we want to calculate them below the x-axis, we'll do that in our next video. Or if there are going to be areas between two functions, we'll do that also in another video.